Here's something that might completely change how we think about data processing. What if the future of artificial intelligence isn't happening on Earth at all, but floating hundreds of miles above our heads in the cold vacuum of space? A Belgian space technology company called Edgx just secured 2.3 million euros in seed funding to make this sci-fi scenario a reality. But here's where it gets controversial. They're betting that traditional ground-based data processing is fundamentally flawed, and they might just be right. The funding injection, spearheaded by IMEC iStart Future Fund alongside the Flanders Future Tech Fund, managed by Flemish investment firm PMV, will turbocharge the commercialization of Edgx's revolutionary Sterna computer system. Think of Sterna as a supercharged brain for satellites, but instead of being powered by typical space-grade components, it harnesses the raw computational muscle of Nvidia technology. Here's the game-changing concept. Instead of satellites capturing massive amounts of raw data and beaming it all back to Earth for analysis, a process that creates enormous bottlenecks and delays, Sterna processes everything directly in orbit. This approach transforms satellites from simple data collectors into intelligent decision-makers floating in space. And this is the part most people miss. Edgx isn't just solving a data processing problem. Their technology could fundamentally reshape how we think about mobile communications. The Sterna system has the capability to power both current 5G networks and future 6G infrastructure directly from space, essentially turning satellites into orbiting cell towers with base station functionality built right in. But the implications go far beyond faster internet. The real power lies in what Edgx calls AI-powered use cases, essentially giving satellites the ability to think and react in real time. Picture this. Instead of waiting hours or days for satellite imagery to be downloaded, processed, and analyzed on Earth, these space-based computers can instantly identify ships navigating remote waters, vehicles moving through conflict zones, or infrastructure damage from natural disasters. When earthquakes strike or floods devastate communities, these orbital AI systems could detect and flag critical situations immediately, potentially saving countless lives through faster emergency response times. The surveillance and reconnaissance applications alone could revolutionize intelligence gathering, though this raises some eyebrow-raising questions about privacy and oversight. Wouter Benoot, who founded Edgx and serves as its chief technology officer, acknowledges the ambitious nature of their mission. As he puts it, going from 0 to 100 on a space startup is ambitious, but this all-or-nothing approach to developing Sterna has created both significant challenges and genuine breakthroughs. The proof will come in February 2026, when Edgx plans to launch their first orbital demonstration aboard a SpaceX Falcon 9 rocket. 2 additional test flights are scheduled for later that year, marking critical milestones in validating whether space-based AI processing can deliver on its revolutionary promises. This development fits into a broader European push for technological sovereignty in space. Just last month, fellow European space company Open Cosmos made headlines by acquiring Portuguese startup Connected, signaling Europe's determination to compete with American and Chinese space technology dominance. But here's the million-dollar question that nobody's really talking about. Is moving our most critical AI processing capabilities into the harsh environment of space actually safer and more reliable than keeping them on solid ground? And what happens when these orbital AI systems start making autonomous decisions that affect people's lives without any human oversight? What's your take on this space-based AI revolution? Are we looking at the future of intelligent computing? Or are we creating new vulnerabilities by putting our digital brains where we can't easily fix them when things go wrong? Should we be excited or concerned about satellites that can think for themselves?